So we have spent a long time looking at linear relationships, two things that when we see how they interact with each other and you graph that interaction or that relationship, you get a line. Well, now we're going to look at scatter plots. This is another way to look at the relationship between two variables that might not be linear, but may be sort of kind of linear, okay? So we have this situation. We are comparing the speed of a car to the distance it's required to stop. And we want to know, are these two things related? Is how fast a car is going related to how long it's going to take it to stop? Now think about that a second. Do you think there's a relationship there? Well, we're going to see if we can tell anything about this by constructing a scatter plot. A scatter plot is what it sounds like. It's going to look like a bunch of dots scattered all over the graph. Okay, so we have the x side of our table is speed. So we're going to put speed on the x-axis. We're going to put distance on the y-axis. We're going to scale our axes. We notice here these are counting by tens, right? So we can probably do the same thing. I'm going to skip some lines to make it easier to read. So I'm going to make 20 there, then 40, 60, 80, 100. My y-axis, I need to go to almost 250. There are 10 lines here, so I'm going to count by 25s. So my second line will be 50, then skip a line 100, 150, 200, 250, okay? And we could title our scatter plot lots of things, but let's title it stopping distance. Okay? So all you're going to do, you're going to treat each of these lines like coordinates. So this right here is the point 20, 42. So we're going to go up to over to 20, We're going to guess where 42 is. It's not going to be exact. We're going to put a dot. Then we're going to go over to 30 and up to 74. It's going to be almost to where that 75 line is. Then we've got the point 40, 116. Looks like it's going to be about right there. 50, 173. Should be about right there. And 60, 248 is right there. You do not connect the dots on a scatter plot. You will notice these are not exactly in a straight line. Okay, remember we could also check, we could find our rates of change, our slope, and we would see that the rates of change are not equal. So this is not exactly a linear relationship, but they sort of resemble a line. We could draw a line through here that would sort of be through those points. So you describe the relationship between two variables on a scatter plot just like you would a line, just like you would slope. If the dots are rising from left to right, we say they have a positive relationship. As speed gets higher, it takes longer, more distance for a car to stop. You would expect that. If the dots happen to be falling from left to right, that would be a negative relationship. If they're just sort of all over the place, not going up, not going down, we would say that is no relationship. Now, a nonlinear relationship, we're just going to look just briefly at that. If I have a bunch of dots that sort of tend to do the same thing, okay, but aren't in a line, and that was really bad with the stylus on the diagram. See how these sort of make a curve? That would be a nonlinear relationship. There appears to be a relationship here, but it's not a line. Okay? Now, another word I want to give you, they might not ask about the relationship, they might ask about correlation. So if you are asked what is the correlation of the scatter plot, that's the same thing as relationship. Okay, so if you see correlation, that means relationship. Notice correlation has the word relation in it. So here's a scatter plot already done. We are looking at sales of hot chocolate, and we're looking at the temperature outside. This is an outside concession stand, and how many cups of hot chocolate were sold. What would you expect as the temperature goes up? What would you expect about the number of cups of hot chocolate sold? You'd expect them to go down, right? So as we can see, that is what tends to happen. The higher the temperature, the lower the amount of hot chocolate that's sold. Okay, so it says explain whether it has a positive, negative, or no relationship. So we would say here that this is a negative relationship because, since it says explain, we need to put some words with it. A higher temperature, higher temp, T-E-M-P, equals fewer cups of hot chocolate. That's not a pretty explanation, but in it is chocolate. It is an explanation, okay? Now, look at this scatter plot here. Are there any dots that sort of seem to be out of place, that sort of don't fit with the data? Do you notice this one right here? It's almost 30 degrees, and about 32 cups were sold. But does it fit with the rest of them? Where would we expect this to be? We'd expect it to be up here somewhere, right? So if you have a dot that doesn't fit the data, that is called an outlier. An outlier doesn't fit the rest of the data. Outliers change numbers when we're looking at statistics. If you think about your grades, let's say you've made A's and B's on everything, 92, 87, 95, 84, and you have all these A's and B's, and then you make a 50 on a test. That's an outlier. What does it do to your average? It brings your average down. It affects the median. It affects lots of things. And on a scatter plot, outliers show up by not being where they should. Okay, I want you to try one. Here's a table. It says it shows the average extra fuel used by drivers in one city due to travel delays in congested areas. Remember that on a horizontal table, the top number is X. Also remember time is almost always your independent variable. The bottom row is Y. Create this scatter plot, then turn it back on and check with mine and see how it compares. So you might have scaled your graph a little differently. I've got year on the x-axis, fuel on the y-axis, and I've plotted my points. Also notice I have a title. So compare yours. It may look a little different, but should look similar to mine. Now I want you to answer these two questions. The first one says to explain whether it shows a positive, negative, or no relationship. So I need some words, not just positive, negative, or no. Tell me why. And then the second one says, if there's a relationship, make a conjecture. A conjecture means to make a guess about how much fuel that will be used in 2020, okay? Conjecture is like an educated guess. So turn the video off, answer these two questions, turn it back on, and we'll talk about it. Okay, so these two variables, the year and the amount of excess fuel used, show a positive relationship, or remember correlation. You might also see that word. Each year that goes up, there's more fuel that's used. Now, as far as the conjecture goes, it's kind of hard to miss this. Your answer should be 40 something. If you said 42, that would be good. If you said 45, that would be good. Anything that would sort of fit with the data and with the table that you see. The way you could miss it if you were to say something like 5, would it be reasonable that in 2020 we're going to go all the way down to 5 excess gallons of fuel based on what we know? Well, no, that would be wrong. And if you said something like 175, that would be way too much based on the data we have. Now, that doesn't mean it wouldn't happen that way, but based on what we see, that would not be a good guess. So something like that would be wrong, but if you're in the ballpark, you're good. Okay? All right, so if you have any questions about scatter plots, write them down and get ready to do your practice.